every moon that might hide alien life. Europa, Jupiter's frozen ocean world. Europa orbits Jupiter 628 million kilometers from Earth, completing one orbit every 3.5 days. Its surface is completely covered in ice, but beneath that ice lies a massive liquid water ocean. That ocean could be up to 100 kilometers deep, 10 times the average depth of Earth's oceans. Tidal forces from Jupiter constantly squeeze and stretch Europa, generating heat from within. That heat keeps the water from freezing solid. The Galileo spacecraft discovered that Europa has its own magnetic field. This suggests an electrically conductive ocean below, in other words, salt water. Salt water is an ideal environment for life. The reddish-brown streaks across the icy surface may be mineral salts or even organic material rising up from the ocean below. At the bottom of that ocean, hydrothermal vents may exist, just like on Earth. Around those vents on Earth, life thrives without any sunlight at all. NASA's Europa Clipper mission is currently on its way. It will fly past Europa more than 50 times, analyzing its atmosphere and surface. We may soon know whether something is living beneath that ice. Enceladus, Saturn's geyser moon. Enceladus is much smaller than Europa, only about 500 kilometers wide. But what it lacks in size, it makes up for an astonishing geological activity. NASA's Cassini spacecraft discovered enormous water plumes erupting from the south pole of Enceladus. These plumes shoot straight into space, carrying water vapor, ice particles, and complex organic compounds. This is direct evidence of a liquid ocean beneath the surface. There's no need to drill down, Enceladus is actively spraying its own contents into space for us to analyze. Cassini flew directly through those plumes and detected molecular hydrogen. Molecular hydrogen is a signature of chemical reactions between hot water and rock, exactly the kind of reactions that feed life at hydrothermal vents on the ocean floor of Earth. Cassini also detected silica, suggesting that water inside Enceladus's ocean is in contact with hot rock at high temperatures. That is the perfect recipe for microbial life. Many scientists consider Enceladus the #1 candidate for life in our solar system. We just need to send a spacecraft to fly through those plumes and analyze what comes out. Titan, Saturn's world with weather. Titan is the only moon in the solar system with a thick atmosphere. That atmosphere is denser than Earth's and composed mainly of nitrogen just like ours. But Titan is bitterly cold. Surface temperatures reach -179 degrees Celsius. At that temperature, water freezes as hard as rock. Instead, Titan has lakes and rivers not of water, but of liquid methane and ethane. Methane on Titan plays the same role water plays on Earth. It evaporates, forms clouds, rains back down, and flows into rivers that empty into lakes. This is a complete climate cycle, just with entirely different chemistry. Could life based on methane rather than water exist here? Scientists don't rule it out. Such life would be completely unlike anything we know. Beneath Titan's icy surface, there may also be a subsurface ocean of liquid water and ammonia. If true, Titan could host two potentially habitable environments simultaneously, one on the surface with methane-based chemistry and one underground with liquid water. NASA's Dragonfly mission is scheduled to land on Titan in 2034. A rotorcraft will fly through Titan's thick atmosphere, sampling soil and analyzing surface chemistry. It will be one of the most exciting missions in the history of space exploration. Ganymede, the largest moon in the solar system. Ganymede is larger than the planet Mercury. It is the biggest moon in the solar system and the only moon known to generate its own magnetic field. The Hubble Space Telescope detected evidence of a saltwater ocean beneath Ganymede's surface. That ocean may contain more water than all of Earth's oceans combined. Ganymede's magnetic field creates auroras, glowing ribbons of light in its atmosphere, similar to the northern lights on Earth. By watching how those auroras oscillate, scientists inferred the presence of a salty ocean below. Salt water conducts electricity and influences the magnetic field in a measurable way. Ganymede's ocean may sit as deep as 800 kilometers beneath the surface. That is a significant challenge. But if hydrothermal vents exist at the bottom of that ocean, life could survive in the deep darkness far below. ESA's JUICE mission is currently en route to Ganymede and is expected to arrive in 2034. Callisto, Jupiter's battered and overlooked moon. Callisto is the most heavily cratered object in the solar system. Its surface is covered in impact craters, billions of years of violent history written in ice and rock. But beneath that surface may lie a liquid water ocean, buried roughly 100 to 200 kilometers down. The Galileo spacecraft detected variations in Jupiter's magnetic field when passing Callisto, suggesting a conductive material inside, possibly salt water. What makes Callisto particularly interesting is its distance from Jupiter. It sits far enough away to avoid the intense radiation that bombards the inner moons. This makes its surface significantly safer and far more accessible for future human missions. Several proposals have already been put forward to use Callisto as a base for future exploration of Jupiter and its moons. It is the most human-friendly destination in the outer solar system. Triton, Neptune's backward moon. Triton is the only large moon in the solar system that orbits in the opposite direction of its host planet. This tells us it was not born alongside Neptune, it was captured from the Kuiper Belt billions of years ago. Voyager 2 flew past Triton in 1989 and discovered something no one expected: nitrogen geysers. From a surface as cold as -235 degrees Celsius, columns of nitrogen gas were shooting 8 kilometers up into the sky. Triton's surface has a strange melanine texture, suggesting geological activity in the past or possibly the present. Beneath the surface, a liquid water ocean may exist, kept warm by tidal forces as Neptune slowly pulls it inward. Triton is gradually spiraling closer to Neptune. In about 3.6 billion years, tidal forces will tear it apart and it will form a new ring system. If life exists on Triton, it is living on borrowed time. Mimas, the Death Star with a secret. Mimas looks exactly like the Death Star from Star Wars, with a massive impact crater taking up nearly a third of its diameter. For decades, scientists assumed it was nothing more than a dead ball of ice with nothing remarkable inside. They were wrong. In 2024, data from the Cassini mission confirmed that Mimas harbors a liquid water ocean beneath its surface. Remarkably, that ocean is very young, only about 25 million years old. This means life, if it exists there at all, would still be in its earliest possible stages. Mimas is a perfect example of how ocean worlds can hide in the most unexpected places. Its surface shows almost no cracks or visible geological activity, unlike Europa or Enceladus. That is exactly why its ocean went undetected for so long. How many other moons are hiding the same secret right now? What these moons are telling us. For most of human history, we assumed life required a star. You needed sunlight, warmth, and the right distance from the sun. That assumption shaped the entire search for life beyond Earth. These moons have completely dismantled that idea. Life does not need sunlight. It only needs liquid water, an energy source, and the right chemistry. And our solar system is filled with hidden ocean worlds sitting beneath layers of frozen ice, far from the sun's warmth. Europa, Enceladus, Titan, Ganymede, Callisto, Triton, Mimas, these are not dead, frozen rocks. They are active, dynamic worlds with internal heat, liquid oceans, and in some cases, the exact chemical signatures we associate with life on Earth. The question is no longer whether life exists beyond Earth. The question is which of these worlds we will explore first, and what we will find when we finally look beneath the ice.